Now to continue with the same type of problem, but this time we'll approach it with left endpoints. Okay, so we'll have sample points will be determined by left endpoints. Endpoints of subintervals. All right, so left endpoints, but we'll still let n equal 4. We'll only use 4 rectangles, again my choice, and delta x then will be the same. We're over the same interval, so 2 minus 0, right endpoint of entire interval minus left endpoint of entire interval divided by n is 1/2. So there's our delta x's right down here, right? Same base lengths. But if we're using the left endpoints, so now the first rectangle height is determined by this point, right? On this first interval, 0, 0 is the left endpoint, so therefore that determines the height. So there's no height, right? Because the function there is 0. 0 squared is 0. So therefore this rectangle has no height, it will contribute no area. It's you might say like a vast under approximation to what's going on here, right? The green above it. Nevertheless, it's what it is, okay? So rectangle 1 should be f of 0 times delta x, which we know is 0 squared times 1/2, okay? So we get 0, okay? So we don't have to worry about that one. Okay, rectangle 2, 3, and 4. Need to add them together. All right, so using left endpoints, here's our left endpoint of the second interval. So mapping up to the curve, we'll have f of that height is f of 0.5, of course. That's that height there. So mapping up to the curve and then drawing a rectangle height over to the side of that rectangle and down. There is our first, you might say, substantial rectangle. So I'll try to cover it over with blue again, something like that. Okay, so what's that one going to be? Well, it's rectangle 2. That is f of 0.5 times delta x, and that will be 0.5 squared times 1/2. Rectangle 3, very similarly. Rectangle 3, there's his delta x, of course. There's the 1/2 value, right? From 1 to 1.5 is a half unit. And now we use the left endpoint of 1 and map it up to the curve, a height of 1, and then that determines the height of the rectangle. Okay, and then the last one, we'll use the left endpoint of this subinterval, left endpoint of 1.5, and go up here, map it up to the curve. So that height is whatever f of 1.5 is. I think we said a second ago was 2.25, so that's that height there. And that determines the height of the fourth rectangle. You notice they're all shorter than before, and this time they'll have to be under the curve. Right? That's not always the case, but it is with this particular problem. So we have our 4 heights determined: 0, f of 0.5, which is 0.25, we showed a minute ago, 1, and 2.25. Those are our 4 heights. Okay. Just color them in here. So these really 4 areas, right? These 4 rectangles, one of which is insignificant because it's 0. It happens sometimes, something to be aware of. So rectangle 3 should be f of 1 times delta x. Rectangle 4 should be f of 1.5 times delta x. And those calculations will be 1 squared times 1/2, 1.5 squared times 1/2. So we'll have 0.25 with a half on the outside. We said we could take the 1/2 out of everything like before. The 0 I'm not worried about. Remember, we are trying to add these together. We're just adding the 4 rectangular areas. So a 0.25 here, a 1 here, and a 2.25 here for that square. Okay, with the 1.5 pulled to the outside, which again you can always do in all these problems because delta x should always be the same. We're using the same size subinterval for every within each problem. So this will be what, 2, 3.5. So 3.5 times a half. So what's that, 1.75? Sounds reasonable. I'll just leave it like that. 1.75. All right. So 1.75. Now from the picture here, again, we can say something a little more tangible, which is that this is certainly an under approximation because all of the areas, right, fell out below the actual area here, right? The blue is always below the green here. So therefore, 1.75 is certainly an under approximation. And it doesn't always work out like this, that the left endpoint is an under and the right endpoint that we did before is an over approximation. It's problem dependent. It's dependent on a lot of things, about the shape of the curve and the type of intervals you pick and things like this. So you can't tell ahead of time. It's only because I have the picture right in front of me I can tell it's so obvious that it's under approximation. So under approximation to the area under f of x equals x squared over the interval 0, 2. So at this point, we have a little bit more knowledge about the actual green area back here, right? We know that the actual area, just these crude approximations, is somewhere between, what was the last one? 3.25 was our over approximation, and 1.75 was our under approximation.